In Lecture 2, we're going to first gain a deep understanding of the three primary macroeconomic indicators. The first being inflation, the next being economic growth, and the last one being unemployment. Now, I would throw in interest rates as well. We're not going to spend too much time on interest rates. But the first big macroeconomic indicator is inflation. Inflation is the percent change in the price level from one year to the next year. Inflation equals what the price level is minus what the price level was a year ago divided by what it was a year ago times 100%. Now, you don't literally multiply it by 100%. You multiply it by 100. So if you multiply by 100%, you're going to get 1. Or 100% is just 1. So you multiply it by 100 after you plug it into the calculator, and then you interpret it as a percent. The Consumer Price Index is a common measure of the price level. The BLS, the Bureau of Labor Statistics, calculates the CPI every month by computing a weighted average of the prices paid by urban consumers for a fixed market basket of consumer goods and services. CPI is calculated each month by holding quantities in the basket constant over time. The CPI basket in 2007 is based on information obtained from the Consumer Expenditure Survey conducted during 2005. Their survey is used to assign weights to each item in the CPI market basket to reflect the average urban household's consumption behavior. Now, because the CPI is used to measure price changes, it is important that the prices recorded refer to exactly the same items. We can use these numbers in the CPI to compare what a fixed basket of goods cost this month with what they cost in some previous month. Now, the CPI is just simply the price level in a given year, or the total cost of the market basket times 100%, divided by the price level in the base year. And the CPI uses a base year of 1983. So the CPI uses a weighted average of the cost in dollars of goods and services. The figure below is from 22.1. It shows the weights used in the CPI market basket. 43% comes from housing, 17% is from transportation, food and beverages is about 15%, medical care is about 6%, recreation is 6%, education and communication is about 6%, apparel is 4%, and other goods and services is 3%. Now, notice how little food and beverages are. For everybody else in the rest of the world, right, food and beverages are closer to between 50 and 100%. It just goes to show you how wealthy a nation we are when only 15% of our consumption is on food and beverages, and 4% is on apparel. Now, the CPI market basket is a collection of 80,000 goods and services that an average household buys in 30 metro areas. The CPI for a given year equals the price level in that year divided by the price level in the base year multiplied by 100, because again, we want to report it in percentages. Okay, suppose I am the typical urban consumer, and the government interviews me to determine what goods should be in the CPI market basket, because I'm the typical urban consumer. Now, the following is something that I might have typically purchased while in my last year of college. Okay, so the average quantity purchased per month for milk was 4 when I was in college, right? And maybe the price in November of 2006 at the grocery store I happened to shop at was $2 per gallon. The total cost of that would be $8. Now, maybe I bought one TV every 100 months. So the average quantity purchased per month would be 0.01. And maybe the price of a television back in November 2006 was $400. So the average money I spend each month is about $4 on televisions. Same thing with computers, except back then, maybe the average computer cost $1,000. So the average amount of money I spent each month on computers is $10, because I'd buy one every 100 months. Now, I own a used town car, but suppose I bought a brand new town car, right? I buy 5 town cars every 1,000 months. And a brand new town car is $50,000. Well, that means I spend, on average, $250 on town cars a month. Now, back in graduate school, I probably didn't eat very well. I'd have 15 Snicker bars a month. Actually, I had more like 30, but let's assume I had 15 a month. Now, back then, they were about 50 cents a piece. So, the total cost I'd spend on Snicker bars on average would be $7.50 a month. Now, because I needed to stay awake, I was in graduate school, I'd have one 32-ounce Pepsi a day. Right? And the price was $1 at the place I purchased them, for a total cost of $30 per month. Now, back in graduate school, like most graduate students, I enjoyed a beverage of the adult kind called Busch Light. So I'd buy, on average, 2 6-packs of Busch Light a month. And the price per 6-pack was $6 at the places I purchased them. So I would spend $12 a month on beer. Now, socks, I'm from Idaho, so I tend to walk around on sidewalks, garages with my socks. So I go through a lot of socks. Maybe I go through 4 socks a month. And I'd buy them really cheaply at $2 a pop. Chickens, I'd buy a whole chicken. I'd buy 5 whole chickens a month, cut them up into meals, and the price of a chicken maybe was $3 at the time. So I'd spend $15 on chickens. I like ribeye steaks. My roommates and I ate lots of ribeye steaks. Rather than going out to dinner, we'd just buy them, cook them on our grill, and we'd spend $100 a month on ribeye steaks. Now, because I was an older graduate student, I need to remain, regular in terms of constipation and all that. So I ate a lot of fiber. So I'd eat 5 boxes of Raisin Bran a month. So the average price of a box of Raisin Bran was about $3 where I bought them. So I'd spend $12 on Raisin Bran a month. Of course, I had to have cable TV because, studying economics and mathematics 12 hours a day, you need to have some downtime. Reading papers all day long, I was too tired to pick up a book and read it. So watch a little cable news, some Discovery Channel, and a couple of movies on TBS and TNT. So each month I'd spend $40 a month on cable TV. Of course, I'm a big college football fan, and I'd watch 5 college football games a month on pay-per-view, which meant that I'd spend $75 a month on college football games. Now, if I'm the typical urban consumer, and this is what I typically spend my money on each month, then the price level, or the cost of the CPI basket in November of 2006 would be $571.50. That's what we call the price level. The price level is the cost of the market basket. Okay, so the price level in November of 2006 is $571.50. Now, if the government keeps track of this cost of this market basket over time, right, and it computes this every month, then we have this series of price levels. Notice back in 1983, the Hal market basket was $279.93. But in 2007, of February, it was $577.73. Now, this is an oversimplification of how the CPI is computed. It's really a 3-year, it really has a 3-year base year. But we're going to make it simple. We're going to say that the month of July in 1983 is the base year. We're just going to keep it nice and simple. Instead of using a 3-year price level average, we're going to just use a month in 1983 as the base year. Okay, so all we're going to really do intuitively is take this price level, 283.62, and we're going to divide all these price levels. We're going to take all of these and divide by 283.62, and then we're going to multiply by 100 to give us a percent. So, dividing the base year, the base month I should say, the base month by 283.62, and then multiplying that by 100 gives us 100% in the month July 1983. Okay, now we divide all the price levels, all the costs of the market basket by $283.62. Now, all these numbers all these black numbers in the price level column were simulated. Okay? I just simulated them. So dividing 279.93 by 283.62 gives us a CPI in April of 1983 of $98 or 98.77%. Doing the same thing in May, June, August, September, October, November. Skip forward to August 2006, September 2006, October, November, December, January, February, we get the CPI. Now, these are the actual CPI numbers that I got from government sources. Okay, and I just simulated these. The government does not publish the price level. The government publishes the CPI. Okay, so all these numbers are again in percentages. Now the inflation rate. The inflation rate is the annual percent change in the CPI. So you take what the CPI is in a given year, you subtract from it what it was a year earlier, and then you divide again by what it was a year earlier, and then you multiply by 100. Okay, so inflation is a positive percent increase in the price level. Disinflation occurs when inflation decreases over time. Deflation, not to be confused with disinflation, deflation is a negative percent change in the price level. Okay, so to compute the inflation rate for July 2009, we take what it is and subtract from it what it was a year earlier. And then we divide by what it was a year earlier, and we multiply by 100. So the inflation rate is a negative 2.10, which means over the course of that year, the general price level fell by 2.1 percentage points. Okay, now we want to compute the inflation rate for August of 2009. We take the CPI, what it is in August of 2009, we subtract from it what it was a year earlier, and then we divide again by what it was a year earlier, and then multiply by 100. And so the inflation rate is a negative 1.48 in August of 2009. So in the course of a year, prices fell on average about 1.48%. Do it again a month later, we take the CPI in September of 2009, what it is in 2009, September, and subtract from it what it was a previous year, divide by what it was the previous year, multiply by 100. And we get inflation, a negative inflation rate of negative 1.29. So prices fell 1.29% over the course of that year, right, in the month of September of 2009. We do it again. The CPI in October 2009 is 216.18. It was 216.57. So the inflation rate in October of 2009 is a negative 0.18. So prices fell 0.18% from the previous year. Now, all of these are deflation because prices are falling over the course of that year for that month. So this is figure 22.2 in the textbook. So here's the CPI from 1977 to 2007. Now notice the price level is rising pretty fast here, and then even faster here, and then it starts to slow a little bit, right? And then the price level is rising very slowly here. Then it starts rising again, then it starts rising very slowly again. And then it's pretty constant from here to here. The inflation rate is the percent change, the yearly percent change in this trend line. So notice that the inflation rate is about 7% in 1977. Okay? But then it jumps up quite a bit to almost, 14% a couple of years later. Now, the higher this curve is, the higher this graph is, the steeper this curve is. So the steepest this curve, the steepest this curve gets is around 1978, 1979, which is why this curve is peaking at that same time. Now, remember that the CPI is flattest right around 1987, which is why the CPI, or the inflation rate, is close to zero just before 1987. Okay, so from this period of time to this period of time, the inflation rate is falling. It's always positive. It's positive here, positive here, positive here, pretty flat here, positive here. So we have inflation throughout this period of time, but the inflation rate is falling. Therefore, this is a disinflationary period. Okay, so prices are most rapidly rising here. That corresponds to a huge inflation rate in the same year. Okay, prices are rising very slowly in this time period, which is why we have low inflation here. Okay, but from here to here we have disinflation. So you could say, generally speaking, from the late 1970s to basically 2007, we've had a period of disinflation. But that disinflation is the greatest from about 1980 to about 1987. Although CPI is used as a cost of living adjustment, COLA, it's not a COLA because it does not measure all the components of the cost of living. Some components are not measured exactly. So the CPI is possibly a biased measure. There's what we call new goods bias. New goods do a better job than the old goods that they replace, but they cost more. The arrival of new goods puts upward bias into the CPI. Then there's the quality change bias. Better cars and televisions cost more than the versions they replace. A price rise due to improved quality is not inflation, but gets measured as inflation. Then there's commodity substitution bias. If beef's price rises faster than chicken's price, people buy more chickens and less beef, right? But remember, the CPI market basket is fixed for a couple years. So there's a commodity substitution bias. Then there's the outlet substitution bias. If prices rise more rapidly, people start using discount stores more frequently. But the way the survey is conducted, surveyors aren't really surveying less. They don't really change where they're surveying prices with respect to grocery stores and supermarkets and malls and whatnot. Okay, so the CPI basket doesn't change to allow for the effects of outlet substitution. Right? For example, when the economy is growing well, people stop buying at Walmart and buy at Target. They stop buying at Target. People that used to shop at Target are now shopping at JCPenney or Sears. People that were shopping at Sears are now maybe shopping at Macy's. When we go into a recession, Target shoppers start shopping at Walmart. Walmart shoppers start shopping at Dollar General, yada, yada, yada. And the CPI doesn't account for those changes in where people shop. Now, the Boston Commission estimated the bias to be about 1.1 percentage points per year. To reduce the bias in the CPI, the BLS now updates the CPI basket every 2 years. So there's still a problem. Okay. Distortion of private contracts is a consequence of the bias in the CPI. Many wage contracts are linked to the CPI. If the CPI is biased, these contracts might deliver an outcome different from that intended by the parties. Example, suppose the UAW and General Motors sign a 3-year wage deal. In the first year, the wage will be $30, which rises by the inflation rate in the next 2 years. Assume this contract will affect 30,000 General Motors employees, each working 40 hours per week, 50 weeks per year. Assume the actual inflation rate is 2%, but bias in the calculation pushes it up to 5%. We don't know that it's actually 2%. Our calculation has it at 5%. Okay, so keeping it simple, the contract results in the following wages. In year one, workers at General Motors receive a wage of $30. In year two, that $30 wage is inflated by the biased CPI calculation. So the wage bumps up to $31.50. If the two parties could somehow ascertain the actual inflation rate, the wage that the employees would be paid would be more like $30.60. Okay. Now in year three, the wage that General Motors pays its employees is adjusted by another 5%. Now notice that there's compounding here, right? The change in wages is not linear. What do I mean by that? Well, from year one to year two, wages rose by $1.50. Well, from year two to year three, they rose by $1.58. That 8 cents is the compounding. So the longer this contract is, the more compounding there is involved with adjusting wages for inflation. Now, again, if the companies were able to ascertain the true inflation rate, which is impossible, then the real wage would have been $31.21. And notice there's very little compounding here, right? From 30 to 60, the wage increased by 60 cents. In wage two, from year two to year three, the wage increased by 61 cents. So there's less compounding because the inflation rate is lower. So total hours worked at General Motors per year, 30,000 employees, 40 hours a week, 50 weeks a year. There's 60 million hours, employee hours, that General Motors has to compensate for. Total labor expenses using the biased inflation number means the total labor expenses for the 3-year contract is $5.7 billion. Total labor expenses using the biased inflation rate that only my mom and God know, because my mom passed away. She's up in heaven now, so she and God are talking, and her and God know what the true inflation rate is. Using the unbiased inflation rate that only God knows, or whoever if you don't believe in God, then what the universe knows. The total labor expenses would have been, the total cost of the contract would have been only $5.5 billion. So General Motors labor expenses are $166 million more than what they should have been if they had been using the true inflation rate number. Now this seems great for the employee, right? If General Motors competitors like Toyota and Honda aren't unionized, then maybe their contracts aren't as generous. Maybe they're not based on, maybe their wage contracts aren't based on the CPI adjustment. Okay? And the longer the contract is, the more detrimental it is to General Motors and its employees, because it drives up the labor cost of General Motors cars more rapidly than the labor costs associated with a Toyota or Honda car. And maybe that's going to explain why General Motors needed to bail out a couple years ago. Biases in the CPI increases government outlays. Close to 1/3 of government outlays are linked directly to the CPI. The CPI is used to adjust, this is a couple years ago, 48 million Social Security benefit payments. And, well, this number here, 22 million, is now over 40 million. So this is before the recession. These numbers are before the recession. So the CPI is used to adjust 22 million food stamp payments back a couple years ago. 4 million pensions for retired military personnel, federal civil servants, and their surviving spouses. Again, this is a number back before the recession. And the budget for 27 million school lunches. Biases in the CPI decrease tax revenue too. The CPI is used to adjust the income levels at which higher tax rates apply. Because tax rates on large incomes are higher than those on small incomes as incomes rise, the burden of taxes would rise relentlessly if these adjustments were not made. The upward bias means tax adjustments overcompensate for rising prices, moving people from higher tax brackets to lower brackets, resulting in a decrease in the amount of taxes paid. So using the CPI for these two things make budget deficits worse, holding everything else constant, because government outlays are compounding more rapidly than they would have had the government used a more realistic version of inflation. Meanwhile, tax revenues are being underpaid because it's trapping more and more people into lower and lower tax brackets. So tax revenues aren't growing as fast when the CPI is used to adjust the income tax brackets. And government outlays are growing much faster, which is widening the budget deficit. Okay, now nominal price and the real price. To compare dollar amounts at different dates, we know the CPI at those dates. Now, the price of a Hershey bar in 1936, according to this website, cost 5 cents, and that was for a 1.5 ounce bar. But when I put this example together, that Hershey bar was $1.10, and the Hershey bar was 1.55 ounces. Now, ignoring the differences in weight, I mean, is anybody going to notice the difference between a 1.5 ounce bar and a 1.55 ounce bar? I doubt it, right? So we'll ignore those differences. Now, on the surface, the bar in 1936 seems like a better deal than the bar that I purchased a couple years ago for $1.10. So, but we can't really compare the 5-cent bar to the $1.10 bar because over time, inflation erodes the purchasing power of a dollar. Okay, so the nominal price of a 1936 Hershey bar in 1936 dollars was 5 cents. That's the nominal price, the sticker price. The price of a 1936 Hershey bar in 2009 dollars, you take the nominal price in 1936, you multiply it by the CPI in 2009 divided by the CPI in 1936. That converts the dollars to, okay, see, the 1936 dollars divided by 1936 dollars is 1, but we're multiplying by 2009 dollars. So doing this converts the 1936 dollars into 2009 dollars. Okay, so the nominal price is 5 cents. The CPI in 2009 was 216.18. The CPI in 1936 was 14. So if you buy a Hershey bar in 1936 using 2009 dollars, that Hershey bar really cost you 77 cents. So you're much better off back then paying 5 cents than you are paying $1.10 today. I can compare this 77 cents to that $1.10 because both are priced in 2009 dollars. Okay. Now let's look at nominal wages versus real wages. Suppose you made $16.73 per hour in 2006. This is the nominal wage, valued in 2006 dollars. If you want to compare wages from year to year, you have to convert them into real values. So the 2006 wage rate in 2006 dollars is $16.73. That's a nominal wage. Now the 2006 wage rate in 1983 dollars, maybe you want to compare it to what I made as a dishwasher as a freshman in high school way back in 1983 when I was making $3.35 an hour washing dishes and preparing the salads and baked potatoes. Okay, so I plug in the $16.73 wage, the nominal wage in 2006 dollars. I multiply that by the CPI in 1983 because I'm going to deflate this back to 1983 dollars, right? I divide it by 2006 CPI because I want the dollars, the 2006 dollars, to cancel. Okay, the CPI in 1983 was 100. The CPI in 2006 is 201.6. 2006 dollars cancel with 2006 dollars, and this is in 1983 dollars. So that wage is the wage that you earned in 2006, right? In real dollars is $8.30, and those dollars are valued in 1983 dollars. So a person that's a dishwasher making $16.73 an hour in 2006 is much better off than I was making $3.35 in 1983. Now there are other price indices. There's the GDP deflator. It's an average price of all goods and services included in the gross domestic product. The GDP deflator is computed by taking the nominal GDP, dividing it by real GDP, multiplying by 100. Since the GDP deflator is a measure of the price level, its percent change is a measure of inflation. The GDP deflator uses information on the current year quantities. It includes new goods. It includes quality improvements, allows for substitution effects of commodities, allows for substitution effects at retail outlets. So the GDP deflator is less affected by the bias of the CPI. However, it uses the CPI, so there is still some bias in the GDP deflator. Then you got the personal consumption expenditure deflator, the PCE deflator. It's similar to the GDP deflator, but is an average of current prices of all goods and services included in consumer expenditure component of GDP. Now, this is what they look like over time. The inflation rate for the GDP deflator is given by the blue curve. The inflation rate of the kind of aqua blue curve is computed from the PCE deflator. And then you have the red line, which is the inflation rate computed from using the CPI. And notice that the peaks and the valleys of inflation using the GDP deflator are less pronounced. The peaks are higher for the CPI, and the valleys are lowest for the CPI, generally speaking. So there's more variance in inflation computed using the CPI than there is in the GDP deflator and the PCE deflator, generally speaking. Okay, so the GDP deflator, why is that? The GDP deflator rises relatively flat compared to the PCE deflator and the CPI. The CPI rises more because the CPI, again, is only 80,000 goods and services, where the PCE is more than that, but less than the goods and services, all goods and services that are included in the GDP deflator. So the CPI overstates the inflation rate. Inflation has costs. Costs include menu costs, right? Now, these menu costs aren't as pronounced as they used to be. A gas station that didn't have a digital sign would have to hire somebody to adjust the prices that you see on their signs. Nowadays, if during a hurricane, people are hoarding gasoline, they drive to a gasoline station, and they're buying more gas than they would normally buy, so there are people stocking up on gasoline. What a gasoline station manager can do now is sit in his or her office and bump the price of gasoline up by, say, 5 cents every 15 minutes to get customer traffic back to more normal levels. Because the gas station owner doesn't want to run out of product, because the gas station owner makes more money off the sodas, snacks, candy bars, beer than he or she does from the sale of gasoline. So that's why Sheetz, a gas station that is common on the East Coast, you can literally, while you're pumping your gas, order a cheeseburger or a hot dog or whatever, a soda, at the gas pump. So menu costs are a lot lower today than they were. Today, it's very easy for a restaurant to print new menus every day because everybody has color printers. 30, 40 years ago, if you're a nice restaurant, you have to have nice menus, and those menus are very costly to produce. You have to hire somebody to print them for you. Today, you can make your own menus. That cost associated with changing your prices is much lower. A lot of restaurants, like fast food restaurants, will have digital menus. Then there's shoe leather costs. Back before World War II in Germany, prices were doubling every day. So if you needed to buy groceries and you're getting off work, you'd have your son go to the bank for you take money out of your savings account, meet you immediately at the grocery store to buy groceries before the prices were changed and doubled. So people were running to the bank more often, or had to run to the bank more often, because they did not want to have, cash in their pocket. If they had cash in their pocket, by the end of the day, the cash in their pocket was worth half as much. So they had to run to the bank a lot. And the shoe, what do we mean by shoe leather costs is soles of shoes were made with leather. So if you run to the bank more often, you're wearing out your shoes more often. And then people just dislike prices rising. And then inflation is kind of like a tax. Governments have been known to print money to pay off debts that they owed. That's what happened in Germany. The governments had to pay off the debts they accrued from going to war with France and England, and they simply just printed money to pay these debts down. You can kind of see that today with quantitative easing. The government's running a huge budget deficit, was printing money to buy bonds directly from government. They were monetizing the debt. That's what quantitative easing was all about. And that generally leads to higher prices. So governments can either tax you by raising your taxes, or they can print money, and if your incomes don't rise, your standard of living is falling. Okay, inflation decreases the purchasing power of the dollar. The dollar does not go as far as it used to. The nominal value of something is in current dollars. The real value of something is measured in the dollars of a given reference base year. For example, CPI's base year is 1983, GDP to deflator's base year is 2005. Macroeconomics makes a big issue of the distinction between nominal values and real values. We have the nominal price versus the real price. We have the nominal wage versus the real wage. We have nominal interest rates versus real interest rates. We have nominal GDP versus real GDP, right? Now, if your wages are keeping up with inflation, right, then you're really no better off than you were a year ago. You're no worse off, you're no better off, right? If, however, your wages aren't keeping up with inflation, the inflation is making you worse off. And that's kind of the situation my family finds themselves in. I haven't been able to get a pay raise in 3 years. Meanwhile, the prices that my family's paying at the grocery store, they're going up. So inflation is eating away at my salary. So in real terms, I'm getting pay cuts because of inflation. Okay, so this figure here from the textbook, figure 22.4, shows how nominal and real wages have changed from 1982 to 2006. Okay, so the nominal wage has risen pretty steadily over that time period. So if you were looking at nominal wages, you would make the incorrect assumption that we're getting better off. If you account for inflation, the real wage is pretty flat. Americans are not really better off, they're not really worse off according to this red line. Okay. Now, inflation has a lot to do with interest rates. Inflation, economic growth rate, and the unemployment rate are the three big macroeconomic indicators. But interest rates are also important. The nominal interest rate is the percent return on a loan expressed in dollars. Real interest rate is the percentage return on a loan calculated by purchasing power. The nominal interest rate adjusted for the effects of inflation. So if the real rate of return is denoted R, and the nominal interest rate is denoted I, with inflation being pi, the real rate of interest is the nominal rate of interest minus the inflation rate. Okay, and so figure 22.5 shows how the real rate and the nominal rate have changed from 1967 to 2007. During the 1970s, the real rate of interest became negative. Down here, it became negative, right? Why was it negative? What does a negative real rate of interest mean? It means that when a bank gives you a loan, they're paying your interest for you. When the real rate of interest is positive, that means you're paying interest to the bank, which is kind of weird, isn't it? The nominal rate of interest generally follows the real rate of interest, but not perfectly, does it? Right? So the difference between the two, the nominal rate of interest and the real rate of interest, is the inflation rate. Well, the reason why the real rate of interest went negative in the late 1970s and the early 1980s is because the inflation rate was so high. So if I take the difference in the nominal rate of interest and the real rate of interest, 10 minus a negative 4 is 14%. Remember in the CPI diagram, Remember it peaked out about 14% in the early 1980s? Well, that's why the real rate of interest in the early 1980s was negative, right? For banks, that's bad because they're paying you interest for you buying a car using a loan you got from the bank. And banks don't like that. Now, the inflation rate in 2007 is 3.5%, which is why the nominal rate of interest is 3.5 percentage points higher than the real interest rate.